Welcome back to the channel. So, in this video, what we are going to focus on is AutoCAD. So, we have been given um, this right here. Okay. So, what we have to do is to write the coordinates for each and every line here from the first one, which is point one to point 12 there. So it's like we have a total of, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 lines, so we have to write the coordinate system. We have to write the coordinates for all the lines from 1 to 12, and what we're using is a relative polar coordinate system. So when it comes to the relative polar coordinate system, how we do it is that you're going to proceed your distance d at an angle theta with what, with an at, like that. So it's going to be like, you're going to say at your distance d, then the angle of theta. Okay, so all you have to know is your theta, which is your angle, and your distance of that line. So for example, if I'm looking at line line 2 to 3, okay, line 2 to 3, I have to look at what is the distance. The distance is 3. What is the angle? The angle is going to be 0, so it's just going to be more like at the distance of 3, then the angle is what, is 0. Why am I saying 0? I'm counting it from the positive x-axis. Okay, so after doing this, what I'm going to do is that I'm going to use the coordinates that I'm going to find from this here, and I'm going to sketch them, or I'm going to draw in AutoCAD. So this is my desktop right here, and my AutoCAD is this one right here. Okay, and I've actually already opened it. It's this one right here, and after I'm done with those coordinates, I'll bring them here and try to sketch and see what I'm going to end up with, and we'll see if you're going to end up with this same profile that we are given here. Okay, so let's dive into this. So first things first, of course I have to start from the first one, which is 1 to 2. So I'll say 1 to 2, 1 to 2. Then here I'm going to put what my relative polar coordinates system, relative polar coordinates are, using the relative polar coordinate system, which is, we are going to say at distance, then the angle of theta. So we look at this part here, which is 1 to 2. So the distance is simply this one right here, like that. Okay, so all you have to do is just to find what that one is. So it's just more like you have something like um, this mini, like a small triangle like that. Then the distance that is at this point here is given as what? It's given as 1, which is this one that you have here. You don't really have to worry about units. Then the angle that you have here is what? Is 45. So it's more like here you have your hypotenuse. Let me use h. So what it simply means here is that your hypotenuse is just simply going to be equals to 1 over what? 1 over 1 over cos 45. Why am I getting this? This is just basically SOHCAHTOA, because cos that angle is equals to the adjacent, which is 1, divided by the hypotenuse, which is h. So you just make your h this about the formula, then you end up with that one there. So you just have to go to your calculator and find what that value is. So you say 1 divided by 1 point sorry 1 divided by cos 45, you get 1.41. Okay, you get 1.41. So it's going to be at 1.41. Let me use the blue color here. So it will be at 1.41, then the angle of 45 degrees, like that. Okay, so the other way you can think of this is that it's just more like, if you have a 1 here, it's quite obvious even here from the 45 special angle. So meaning this one is going to be root 2. So if you say um, square root of root 2 is going to be, it still be 1.41, which is that one there. Okay, so we move to the next point, the next line rather, which is 2 to 3. So we said 2 to 3. So from 2 to 3, the distance that we have is what? Is a 3. That one is quite straightforward. The distance is a 3, and the angle is what? Is 0. I'm counting from the positive x-axis. Then let me look at this one here. Okay, So that one, that is our 3 to 4. Okay, so the distance that we have is a 1, so I'm going to say at 1, then the angle is what? So there are two ways to see this. So it's more like you have something like this. So when you have this, that is more like your y-axis. This line here, from, let me say this is 0. Let me say this is 0, then let me put A and B here. If you're moving from 0 to A, the angle that you're using is positive what? Is positive 90. Okay, then when you're moving from O to B, you can either say minus 90, or you can use what? Or you can use 270. It's still going to give you one and the same thing. Okay, so here is just more like um I've moved like, since this is my positive x-axis, like that, I can come like that, which is minus 90, or I can move from the positive x-axis, I come like that, which is going to be 270. Okay, so that's how you see that one. So it simply means our from 3 to 4 is going to be at 1, then the angle, let me use minus 90, or you can yourself, you can try to use 270. It will still be okay, or I'll try it when we'll be using AutoCAD. So let me look at now from 4 to 5, from 4 to 5, like from this point, that line there. So that is also pretty straightforward. So the distance that you have there is a 2, so that will be at 2, then the angle is what? The angle is 0. Okay, so then let's look at from 5 to 6, which is pretty straightforward. So from 5 to 6, how is it going to be? It's going to be at, the distance that we have is also a 2. Okay, that will be a 2, then at an angle of, so when you think of it this way, this is our x-axis, so this angle here that you have is just 180 minus the 135. Okay, so that would be 180 minus 135, which is 45, at an angle of 45. Why am I getting why am I subtracting from 180 there? So this is very simple. It's just more like this. So the straight line is equivalent to what? To 180. So if I cut part of it, then I say, okay, if this part is 135, as it is given, so this one here will have to be my, let's say this is my alpha, so it's more like alpha plus 135, I'm supposed to get 180, so I just get my alpha by subtracting 135 from 180, of which we get 45 degrees. So this is degrees, that's degrees, that's degrees, like that. Okay, then let's move to 6 to 7. 6 to 7 is pretty simple. So the distance we have been given as 3, then the angle is 90, because like this is our x-axis, we are opening like that. So you can either say 90 or minus 270. I will just say positive 90, like that. Then let's look at from 7 to 8. Okay, so from 7 to 8 is also pretty straightforward. That is at the distance of um, I forgot to put that distance. The distance is actually 1 as well. So this is a 1 right here. So at a distance of 1, um, at a distance of 1, then the angle is so 7 to 8. It's more like this is more like it's like just like on the x-axis. So the way to do this is you can either say minus 360, or you can just say 180, since it's on the other side, because like if you have 0 this side, or 2 pi, which is your 360, what is this side is what is pi. So when you go on this side, is pi. When you go this side, is what is 2 pi or 0. Okay, so that one is going to be at 180. So actually it's just more like you have moved from, let's say this is our positive x-axis, you move until you reach this point, that will be your 180. Yeah, so we are still considering the fact that we are reading from the positive x-axis. Okay, so let's look at from 8 to 9. 8 to 9. So from 8 to 9, this is simply at the distance is 1, the angle is 90. I believe you know this by now. So you can even actually try to pause the video and find those, then you compare with what I'm going to find. Then from 9 to 10, from 9 to 10 is going to be, the distance is given as 3, then the angle is going to be 180, like that. Then from 10 to 11, which is this portion right here, I've actually also forgotten to put the distance. So this distance right here is 1.4, so it's going to be at 1.4, then the angle of 270 or minus 90. So here I use minus 90, which is 3 to 4, which is this one here, but this one I've used 270. You observe that for both, the line is still going to come down when you draw it on AutoCAD. Then here, let's say from 11 to 12. So 11 to 12 is going to be at the distance is 2.6, then the angle is 180, like we are going in this direction. Then the last one, which is 12 to 1. Okay, 12 to 1. So 12 to 1, uh, from 12 to 1, how we are going to come up with it is this way. Let me see. Actually, from 12 to 1, will there be need for me to use a coordinate system here? Um, let me see, let me see, let me see, let me see. Okay, so let me see how we can come up with this one here. Um, so if this is 45 right here, then let's put up something like this. Okay, something like that. How is this one going to be? Actually, for this one, I think how it's going to be is that I'm just going to look at it this way. Let me, it's just more like it's something like that, then, and coming down like that, and coming down like that there. So I just have to know what this angle is and what the distance here is, then I'll be able to find what my hypotenuse is. Okay, so let's see if we can reason from what we have here. So from, if I look at this one here, let me try to draw a straight line like this. Just try to erase that part. So if I draw a straight line like this, okay, so from this point to that point I've been given as 1, then here to here I've been given as 3, then I can find what is here like that. Okay, so that I know all of it, like from the top to bottom. So here there is a 1, then here there is a 3, then let me find what is here. So what is there, the way I can find it is that I have a triangle. I can make up a triangle here. How can I make up a triangle? It's going to be something like that. Okay, it's going to be something like that. So it's just about the matter of you using your engineering judgment here. So how this one is going to be is that if you put up that triangle, if you put up that triangle like that, so here you have been given as a 2. Okay, so you have a 2 here, then you have what? You have 45. So it's this 2 right that is here, which is my hypotenuse. Then I'm looking for the opposite there. So you observe to say I can use sine. You know that sine 45 is equals to my opposite divide by hypotenuse there. So my opposite is equals to hypotenuse sine 45. So opposite is equals to my hypotenuse, which is a 2, then sine 45. Let me see what I'm going to get when you say 2 sine 45. You're going to get 1.41. So here you also get 1.41 like that. So then this is 3 and that's a 1. So how is this helpful, you might ask? Okay, how is this helpful? So I want to think of it this way. um, if I have uh, let's say this triangle like that, which is representing this portion here, which is this one there like that. So I found out that at this point here on this side I have 1 point, 1 point, actually not 1 point, the total, which is everything that I've found there. So it's like 1.41, 1.41, 1.41 plus 3 plus 1, which is 5.41. So I just have to know what is there. Okay, and how I find what is there is that if you look at this point here, I've been given a 1, so I have a 1 right here. Hence I can use the Pythagoras theorem. So my hypotenuse here is just going to be hypotenuse, which is going to be equal to the square root of 1 squared, which is a 1, plus 5 5.41 squared, which is 29.2827. So 29.27. So 29.27 plus 1, then the square root of that, I'm getting this side, which is 5 point 5.50, like that. So this is 5.50. So I know, because of rounding off, this might not really touch at that point when we draw, but it will really help. So we are saying at so now how we get the angle, you look at this part, so you're moving like that. Okay, so you just have to know what is here like that. So you know to say this is just more like creating kind of some kind of like a Z, because here you have a 45. Okay, you have a 45, which is uh okay, that's not really 45. Let me see what it is equivalent to here. Actually, we can use, we can find what is here. It will give us what is there like that. Okay, because this is not 45. Remember to say 45 is just this small part there like that. So what I can do is that I can use tan theta. So tan theta is equals to my 5.41. So that will be I can say 5.41 divided by 1, which is still the same. Then I'll say, so the angle that I get is 70, that is 79.53. So you can add this with 180, so that is plus 180, which is going to be 259.52. So that would be at the distance you have found, that is 5.0, then the angle is 259.53, like that. Okay, so we are basically done. So let's go ahead and put this in AutoCAD. We see what we are going to end up with. Okay, so maybe we might encounter some hiccups on this same 12 to 1, but I believe the rest is just going to be okay. So what I'll do is that I'll come to AutoCAD here like that. Then here I'll just pick the line command, which is at this point, like on my top, kind of like on the home. That's the first one. That's a line command. If I can't get it from there, I can just let me say escape. I can just come in the command part here. Then I just search line, and it's going to come, which is this one here. But I can just get it from this point like that. So if we go back to our AutoCAD, sorry, this part, 1 to 2 is at 1.41 comma 45, 1.41 comma 45. So I will just come here and say I will just place at any point. I can choose here, I can choose here, I can just go on any point. So let me just put this, let me start from this point here. So we are saying you have observed my distance is increasing. That one that is in blue is increasing, and the angle that is down there. So I'll just go on my keyboard. I'll say at 1.41, then an angle of 45. I'll just say 45, then I'll enter. There it is. Okay, let's look at the next one. So the next one is um, at 3,0. Okay, at 3,0. um, so you just try to write this somewhere so that it will be very much easier for you to relate with what I'm talking about. Let me just try to quickly write them somewhere. So that is the second one, which is 2 to 3. It's 3 angle of 0. Then 3 to 4. 3 to 4 we have 1 at an angle of minus 90, as we have said. Then 4 to 5, it's 1 comma 1 to the angle of 0. Then 5 to 6, it's at 2 with the angle of 45. Then 6 to 7, it's 3 at an angle of 90. Then 7 to 8, it's 1 at 1 at an angle of 180. Then 8 to 9, it's 1 at an angle of 90. Then 9 to 10, 9 to 10 is at 3 with an angle of 180. Then 10 to 11, we have said it's 1.4. Okay, 1.4 at an angle of 270. Then 11 to 12, 11 to 12, 11 to 12, it's 2.6 at an angle of 180. Then 12 to 1, 12 to 1, we have found that that is 5.5 at an angle of 259.3. Okay, so I can go back to my AutoCAD there. Okay, I can go back to my AutoCAD, so I can continue. So I've done 1 to 2. Then 2 to 3, it's at a distance of 3. Then the angle of 0, I just press 0 there, I enter like that. Then that is 2 to 3. Then 3 to 4 is at 1. It's at 1. The angle of, I can either say minus 90 or 270. Let me say minus 90 to come there like that. Then that is and now I'm going to 4 to 5. 4 to 5 is at 1. Let me see, that's that 4 to 5. Okay, let me just try to confirm it. Okay, 3 to 4. Then 4 to 5 is actually 2. 2 with an angle of 0. Yeah. So it's at 2. Then with an angle of 0, I enter like that. Then the other one, that is 5 to 6. 5 to 6, it's at 2. Then an angle of 45. 45, I enter like that. Then 6 to 7. 6 to 7 is at 3 with an angle of 90, meaning going up like that. Then 7 to 8, it's at 7 to 8 is at 1. Okay, then with an angle of 180. So 180, meaning going on my left like that. Then 8 to 9, it's at 1 with an angle of, so here is 90. Let me show you by saying minus 270, which is going to still go up as well. Minus 270, it will still go up like that. Then the other one, which is 9 to 10. So my 9 to 10 is at 3, with the angle of 180, like that. Then then my 10 to 11, 10 to 11, it's at 1.4, then an angle of 270, meaning it's coming down, or you can say minus 90, and that's 270, like that. Then 11 to 12, it's at 11 to 12, we have found is 2.6, with an angle of 180, like that. Then the last one, which just comes to join at that point. Let's see if it's going to join. We found that the distance was 5.5. Or maybe before I do that, let me just go back to the line here. So I'll come and pick at this point. Okay, let me give it a try. So we say the distance we found 5.5 at 5.5, then an angle of 259.53, which is a bit longer. Okay, so let me just undo this, like that. So there might be an error when I performed the calculations there, for that part. Okay, so if that is 45, then so insert 2 sine 45, we got that, plus 3 plus 1, that is 4 point that. That's squared. Okay, so let me just try to redo it again for the last part. So here we have a 1, we have a 3. What we have down here is what we have down there is, let me just try to add it. We say it is 2 sine 45, which is 1.4, plus the 3 plus the 1, which is 5.41 squared. We get okay, so let me see. So at this side, at this portion, I have a 1, then this portion I have a 3, then this part here is equals to, I'll find that is 1.41. How I'm finding this is that it's just like a triangle like this. So you have a 2 here and you have a 45 there. So sine 45 is equals to what you have here, which is your opposite, divide by 2, which is your hypotenuse. So I'm just saying 2 sine 45, that's where I'm getting the 1.5 from. So adding everything here like that, I'm getting 1 plus 1.41 plus 3, I'm getting 5.41. Okay, then down here I have a 1. Okay, so if you say 5.441 squared, the 5.41 squared, which is 5.41 times 5.41, I get 29. Then when I add a 1, I get 30. Then the square root of that is 5 point. I'm still getting the same. So where could be the error? Okay, so I believe where the error is arising from is that I'm making an assumption that the distance that I have here and the distance that I have here is the same as the distance that I have. Oh wait, okay. I think I see where it is coming from. So I think I should just calculate the distance from this point to the bottom part there. Then I use it with the one. Yeah. So up to this point here, what do we have? So what I'll do is that I'll just subtract, since I have 1.4 here, okay, I have 1.4, then I'll subtract this one. Um, Actually, on from everything that I have, okay, from everything that I have, which is my 5.41, I'll subtract the 1.4, which is up to this top part here, like this top part there. Let me subtract it. So I'll say my 5.41 minus just a 5.4 minus 1.4. I'm getting a 4. So that's a 4. So it simply means I have a 4 right here and I have a 1. So I'm simply saying 4 squared, which is 16. So I'm simply saying 16 plus 1, which is 17. The square root of 17 is 4.1, like that. Okay, so meaning this distance that I have right here is not supposed to be 5.5. That was an error. This is supposed to be 4.1, and I can do this, make the same correction here. This is going to be 4.1, but the angle remains the same. So let's go ahead and plug in the 4.1 in AutoCAD and see what we are going to get. So I'll go back to the line command, um, go back to the line, then I'll pick this point, then I'll say at a distance of 4 point. My calculator said 1 2. Let me put 4 decimal places. Then my angle is, we have said it's 259 point 53, and I'll just press enter like that, and there we have it. So this of course doesn't seem to fit quite well. Just try to zoom it in. So I can expand this, and there we have it. So there's this part here that seems not to add up here. Just try to use this. That seems not to add up, and that might be due to me rounding off the what? Rounding off the value of the angle there. Okay, but basically that's how we go about the relative polar coordinate system in AutoCAD, and that's how you can use AutoCAD itself to try to make sense out of everything that you were doing. But otherwise, that's how it's done. Yeah, thank you very much for watching.